In this video, we're going to talk about hypothesis testing. We're going to talk about an introduction of what hypothesis testings are, and then we're going to go more specifically into the t-test. So first off, what's the point of doing hypothesis testings? Well, we often have claims especially in advertisement, where we're told that a population is better than another one, right? So we can have a manufacturer of insect repellent might claim that on average, their product is effective for longer than 6 hours. Well, this is a statistical hypothesis, right? And we want to decide whether the statistical hypothesis is reasonable or even justified. So, in order to do that, we're going to conduct what's called hypothesis testings. And hypothesis testings, we have three key components. We're going to be formulating a hypothesis. We're going to collect data from a sample. So in your IB questions, this data will be given in the question. For your IAs, you're going to be collecting the data yourself. And then from there, we're going to do some mathematical calculations and we're going to make a decision based on all of this. So the point of a hypothesis testing is really to claim if a certain data makes sense, right? So can we say that an insect repellent is efficient for longer than 6 hours, right? So these claims, we need to make sure that they're either realistic or not. In order to choose the stats test, we have three that we're going to be covering in this syllabus. So we have our chi-squared independence test, our chi-squared goodness of fit, and we have t-test. If ever you're wondering which test you need in order to evaluate your situation, this is a really useful video. It's especially useful to choose your stats test for an IB biology course, but it's really useful for our course as well. So I encourage you to watch this one. What we need to know for our course is that we have three steps we are always going to follow regardless of what test we choose. We're going to state the null and alternative hypothesis. We're going to write this down on our test papers. We're going to calculate the p-value using our calculators. We're going to write down the p-value on our test papers. And then we're going to state our conclusion based on the comparisons between the calculated p-value and the significance level, which is something that's going to be given in the question. And we'll go more into detail about what this conclusion is. Now let's get started and talk about our t-test. Why would we want to use a t-test? Well, t-tests are the tests that we're using if we're comparing means of population. Now we could be doing a one sample t-test. In this case, we would be comparing one sample, so a certain data or specific statistics given about this sample, and we're comparing it to a mean. So, for example, of this is students in a computer class are tested to see if they are above the world average for 40 words per minute. So you see that the compared mean in this case is 40 words per minute. So it's given in the question. And we're going to be collecting data about this computer class. So that's a one sample. And then a two sample t-test, well, we're looking at two separate samples. We collect their data or we're given information about both of these and we compare them one with each other. So an example of that is two teachers are comparing the scores on the most recent test to determine which class has the stronger understanding of this topic. So the difference between these two is just if you have one sample that the data is given or you have two. So it's going to be a little bit different for the calculator use, but in both cases, our goal is comparing the means of our population. Okay, for a t-distribution, this is the t-distribution in red. So notice that it's very similar to a normal distribution. Now, in the IB, you do not need to know about this t-distribution. I just like to explain it if ever it helps for your general understanding. And that's also the reason why we call it a t-test in the first place, because we're using a t-distribution. The assumptions that we're going to be using is that your samples are independent from each other. So we need to make sure that both samples don't overlap. We don't have like the same individual in both. It follows something similar to a normal distribution. And we're going to always know what the variance is. Again, you don't really need to know these specifics. The most important thing in this slide is that the samples are independent from each other. Okay, at the beginning of this video, I said that we are going to be calculating a p-value. So the calculator will be giving us this p-value. Now, what does this p-value actually represent for us? It's going to be a probability given to us as a decimal. And this p-value represents the probability that our null hypothesis happening by chance. So in other words, it's the probability of the null hypothesis being true. So we're going to get a certain decimal value, and that's going to be the probability of a null hypothesis being true. When doing our hypothesis testings, we're always asking ourselves, is the probability of the null hypothesis occurring by chance or so unlikely that we reject our null hypothesis? If we reject our null hypothesis, well, by default, we're going to be accepting what's called the alternative hypothesis. So the smaller this p-value, the smaller the probability of the hypothesis being true, the more likely we are going to decide, well, this is too unlikely. Therefore, I'm rejecting this null hypothesis. I don't think that it makes reasonable sense to accept it. So we're just going to reject that. And how will we decide if this p-value is too small? Well, we're going to be comparing it to what's called a significance level, and this significance level will be given to you in each question. At this point in the video, if everything I'm talking about doesn't completely make sense, that's okay. We're going to do a lot of examples to try and understand all of this information. Hello, in this video, we're going to talk about a two-sample t-test. So, first, let's talk about the difference between a one-sample and a two-sample t-test. What you're going to be having now is you're going to be having two samples, and both of them we're going to be given information about our sample. The information could be given to us in terms of data, or it could be given to us in terms of statistics, like we saw for the first one-sample t-test. Every time you're doing a two-sample t-test, we will always have to tell our calculator that we are doing a pooled t-test. What's the difference between pooled versus unpooled? Well, if you would be interested in knowing, you should have noticed that your calculator has a difference. So in a pooled test, it's assumed that the variances of the two populations are the same, and the samples are therefore combined, or they're pooled to estimate the combined variance together. However, the other way is unpooled t-test. So this is when the variances are assumed to be different. In the IB, in the SL course, every single t-test we're going to be doing will be pooled. So you'll see there's going to be a special button we need to change on our calculators. So the other difference is that the null hypothesis is no longer that our mean of our population is equal to a number. It's going to be that the mean of population 1 is equal to the mean of population 2. Okay, what does that look like on your calculator? When you're going to be using your calculator, we're going to be having a window that looks something like this, where we get to input either data, that's what's missing here, the data, or the statistics, and then we are going to be playing around with this. What are the steps? Always the same 4 steps. Our null and alternative is the first one. So our null is always that our two means are equal to each other. And then the alternative, you get to choose. One's either bigger than, smaller than, or not equal to. The next step is going to be using your calculator in order to find this p-value. So in your calculator, you're going to select a two-sample t-test. Always click that it's pooled. Notice pooled, we always need to change that button to yes. And then depending on the information given, either we're going to input data or we're going to input statistics. Your third step is to calculate this p-value in order to make our conclusion. So remembering that if we're rejecting our null hypothesis, if our p-value is smaller than our significance level. And the last step is putting it into context. Without further ado, let's try some questions. Example 2. One common example is when testing a new treatment for a medication. So suppose you want to determine if a new antibiotic cream will help heal a cut faster, i.e. less time, than the existing treatment. So you create two groups and you give one group the new cream and the other group you give them the old cream. And then you record how many days it takes to heal. We're going to be doing this at a 5% level of significance. Okay, so we have data for the time of healing for the new cream and the time of healing for the old cream. First, let's talk about our hypotheses. So both of these are independent, so we can use our t-test. And then we're going to talk about the means. First, I always want you to label what the means are. So mu1, we're going to label it as the old cream. You can choose the new cream as long as you're consistent throughout. And I'm going to say that mu2 is my new cream. So the null hypothesis is that they're going to be equal to each other. The alternative hypothesis, remember, we want to prove that our new cream is faster. So we want to prove that the new cream, the mean of healing, is less than the old cream. So we want new to be less than old. We have to put it in order 1 and then 2. So we want the old to be bigger than the new. So my alternative hypothesis is that my old is bigger than the new. So these are the first step. Second step is we're going to be using our calculators. Since we're given data here, our very first step in our calculator is going to make sure that our lists are edited. So you can pause the video and put your list for making sure your 1 is your old, right? So your old should be in list 1, and then your new should be in list 2. Once you have your old in list 1 and your new in list 2, we can do a stats calculation test. So we're doing a 2-sample t-test. Instead of having statistics, we are given data. Our list 1 is the old, which is going to be in L1. Our L2 is the new. Our frequency is 1. And then we said that our alternative is that the old is bigger than the new. Pooled, always yes. And then we are going to calculate. And then we get our p-value here. Our p-value is 0.0451. That is smaller than our significance level. So we can look at our conclusions. So our next step is going to be to look at our p-value. Our p-value is in fact smaller than our significance level. So therefore, we're going to reject the null hypothesis. Since we reject the null hypothesis, we're accepting the alternative. So we're accepting the fact that the new medication is in fact better than the old medication.